Given that theta is in standard position in quadrant 4 and cos theta equals 2/5, the start of this question sounds like something we did back in chapter 6. In fact, we called these triangle questions because it made sense to draw a picture of a triangle to help us. So we're going to do that again. We know that it's in quadrant 4. We can label it with our reference angle. And since we know that cos is 2/5, we can label the adjacent side and the hypotenuse of that triangle. A squared plus b squared equals c squared. And you would know that that side is the square root of 21. Now in part A, it's asking us to find sine of 2 theta. And we have our new formula on our formula sheet. Again, you must memorize these, even though they're on your formula sheet, because otherwise you won't be able to use them fast enough. Sine 2 theta is equal to 2 sine theta cos theta. Do I know what sine of theta is? Do I know what cos of theta is? What I mean by not being able to use them fast enough is sometimes in a proof, something like 2 sine theta cos theta appears. And if you don't have that in your mind that that's equal to a sine 2 theta, you might miss that at that moment. More often, sine 2 theta comes up in a solving question or a proof, and you have to say, hey, I know something to do with that. So by memorized, I mean like mostly memorized. If you don't have it completely memorized, but at least you recognize that and say, hey, I should do something with that, I'll check my formula sheet. Okay? Now the question gave us that cos of theta was 2/5, so I can fill that in right away. How does my triangle tell me what sine of theta is? Opposite over hypotenuse. And because it's in quadrant 4, it'll be negative. So the biggest mistake here is people forget the negative because they forget the cast rule. And now if I multiply this all out, why does the 2 only multiply on the top? Because it's 2 over 1. So we get negative 4 root 21 over 25. Part B asks us to find cos of 2 theta. And you have choices of 3 formulas. And all 3 formulas will give you the right answer. However, one of them I would say is better to use in this situation than the others. Okay? So of the 3 formulas, we have cos squared alpha minus sine squared alpha, 1 minus 2 sine squared alpha, and 2 cos squared alpha minus 1. So our double angle formulas are right here, and here are our 3 cos ones. I want you to consider the question, read the question again, and then in part B, make a decision which one you think would be the best one to use. And then I'll tell you which one I think would be the best one to use. Even though all 3 of them will give you the right answer, but one is better than the others. So have you picked one and have a reason? So I'm choosing 2 cos squared theta minus 1. Why? Well, I know what cos of theta is. Cos of theta is 2/5. So cos squared of theta will be 2/5 squared minus 1. The reason why this would be the best one is, did you have to do any solving to figure out cos of theta? No, it was given to you in the question. Any of the other formulas uses sine squared, which we figured out sine of theta was negative root 21 over 5. But we had to solve that. And if you would have made a little mistake in solving it, like forgetting the negative, you would lose marks in part B as well. So anytime you can use given information in a question rather than additional stuff you solve for, it's technically better because you're going to make less mistakes or have the chance of making less mistakes. Order of operations, what do you do first? You square. So this will be 4 over 25 minus 1. How do I multiply by 2? 8 over 25. How do I subtract fractions? Need a common denominator. Negative 17 over 25. So we just solved for cos of 2 theta and sine of 2 theta. Theta's in quadrant 4. What quadrant is 2 theta in? Quadrant 3. Because the question says angle theta is in quadrant 4. Whew, blow my mind. But now, why do we know that 2 theta is in quadrant 3? Because both sine of 2 theta and cos of 2 theta are negative. So according to our cast rule, where is sine and cos both negative? Quadrant 3. Okay, questions for practice on this one. Number 9. Okay, but before we do 9, I'm going to give you a 1.5 and a 1.75 question before question 2. You can write it on the top of page 65. So on the top of page 65, we're going to do 2 more examples. 655. Sorry. I should have stuttered 65. And then it would have been 5. Fine. 65. Okay. So evaluate. What does the word evaluate mean? Evaluate means get an answer, an exact answer. This would be a non-calculator question. And this is a great example of where I ask you to have things memorized. It's a pi over 12 question, someone said. Perfect. If this was a pi over 12 question, pi over 12 questions are usually worth 3 or 4 marks on an exam. And this one has how many pi over 12s? 2. So this would either be, if you thought of this as a pi over 12 question on an exam, this would be worth either 6 or 8 marks. I've seen this on the exam. It's worth 2 marks.
How do you tell it's pi over 12 question?
Well, if you think of it as a pi over 12 question because you see a pi over 12, right? You actually make the question harder for yourself. Because the other thing you should recognize in this one is this matches up with a 2 sine theta cos theta formula. Where do we have our 2 sine theta cos theta formula? On our formula sheet we have that sine 2 alpha is 2 sine alpha cos alpha. And if you recognize that instead of the pi over 12, you're going to save yourself about 17 minutes of work. Because if you can do this as a pi over 12 question, and it will take about 17 minutes longer than if you do it as a double angle. And so those are both the same. So we can say that 2 sine of pi over 12 cos of pi over 12 is equal to sine of 2 times pi over 12, which reduces to sine of pi over 6, which is on your pi plate and is equal to a half. Whoa, what?
Oh, okay, I see.
So I recognized this as the right side of this formula. So I switched it to the left side of the formula. That's what a formula does. That's what an identity does. It says they're interchangeable. So what was my alpha? My alpha was pi over 12. What's the left side of my formula here? 2 times alpha. So I wrote 2 times pi over 12. But if you didn't have this formula memorized, you would probably do exactly what Lindsay did when she saw it right away and said, it's a pi over 12 question. And if you started answering it like a pi over 12 question from this morning, it's going to take a lot longer. I don't know if it's exactly 17 minutes. I made that up. But it's going to take longer. I like done statistics. I made 800 students do it the long way and timed them. So here is our last example before we continue. Okay, evaluate. This one's an easier one because I already did the first one. That makes this easier. And it's a pi over 8 question, which doesn't trigger pi over 12 questions. So this, we have this formula, cos 2 alpha (1 minus 2 sine squared alpha). And so I can notice that this is my alpha and make it equal to cos 2 times pi over 8. Which is cos of pi over 4.